Okay, let's talk about compression springs. We're going to do this drawing, and it's a little complicated. Okay, what we're doing a spring. You've all seen a spring. Okay, it's a coil. These are coil springs, and we're trying to draw a 2D representation of a 3D coiled object. Now, Inventor will create springs for you based on some different inputs, but they don't look exactly like they do when we draw them in AutoCAD. And here's one that was created in Inventor, and I've modified it to where the ends are flat and ground, because this is a fairly typical type of spring, okay, for a larger piece of wire or for a larger piece of material. Smaller springs, like you might find in a ballpoint pen, the ends don't have any kind of special treatment to them. But these things work, they're compression springs. So when you push in on the ends, it compresses them, and that provides your strength, okay? Now, just give you an idea what the thing looks like. And this DWF file is available in Blackboard for you to look at if you so desire. But what you're drawing will be similar to this, but a little bit different, okay? All right, here's what your finished drawing is going to look like. And what I've done is I've laid out a series of steps here on how to get to where you're going. We have a few measurements that we want to deal with. The first of which is the wire diameter, or the wire size is what it's called. And that would be the diameter of the piece of material that the spring is made out of, okay? Then we have the pitch, which is the distance from center to center of coil, okay? And then we have pitch diameter, which is the diameter dimension from one side of the coil to the opposite side of the coil. And then we have the overall length, or the compressed length. I say compressed length, the resting length of the spring, okay? All right, so what we will do to start with here is draw you a center line and then offset it so that you've established your pitch diameter on either side. And then since we're drawing this thing in a horizontal format, it'd be easier if you do it that way. And then draw two end lines, which are the overall length of the spring, okay? And then what I did is I drew a circle that has a diameter of my wire size, okay? And I popped one in place here at the edge, and then I copied it, the pitch, and the pitch is the same from one coil to the other coil to the other coil, okay? On the opposite side, you can copy two of them and center them on the end and then trim them back, because you're going to have a half of a piece of a spring once you get to the opposite side. So there's your first step. Okay, next step. On this side, you draw 45-degree lines from the center of the coil, okay? And then where they meet, you would draw a vertical line down to where it crosses on the opposite side. This will be the location of your circles on that opposite side, okay? And I basically just copied my circles down and placed the three of them there. So this particular spring that I'm demonstrating with here is what would be called a 5-coil spring. Okay, so you end up drawing 4 complete coils here, and then you've got 2 half circles on the opposite side. Okay, because if you count the number of coils that it loops around, we would have 5 complete turns as it goes around. Now that's the easy part. Here comes the more difficult part. And in drawing this, I come down here to my object snaps. I'm going to be sure and turn off quadrant, but turn on tangent. And I'm still leaving center turned on because we're doing some copying and things like that. Now this one starts. These lines are not at the quadrant points. They are at tangents. So let's look at this line here first. It does go from the quadrant point to tangent on the opposite coil. Okay. And that's the ending part that's ground down. All of the rest of them, until you get down to this last one that comes down here, will be tangents. And they go tangent of circle to tangent of circle. And once you've drawn a few of these across, you need at least one set in your normal pitch before you start copying. Okay. And the way to draw these things, I'll just demonstrate over here on this one. You start, you go line and then type tang to force it to do an object snap for a tangent, and then just click on that line. And then you come down here, and since we got our tangent object snap turned on, it's not going to pick it up because of the center. Okay, so we can type tang again, and we get a tangent object snap. See, it is not snapping to the quadrant. Okay. All right, so you're going to do a series of these, and then we're going to start trimming and turning them into hidden lines. Now, to make it, of course, this one is a hidden line, and let me just pull up. Here's the handout you're going to get when you're in class, and so you'll be able to see what is hidden and what is visible in looking across this image here on the bottom. Okay. So you just got to remember the things that this thing is coiling. It starts here, coils to the back, comes around to the front here, and then comes towards you up and back to here. Then it coils, it goes away from you, comes down, back towards the front to the bottom, and then from here it comes forward and it goes up. So you had it trying to think and remember that this is a coil that you're dealing with. Okay, so how do we deal with changing out hidden lines and things like that? Okay, what you do is you do a single point break. Okay, so let's just say I'll just demonstrate on this line. So I go to my modify tab and go single point break, and I select my object I want to break, and then I click on the break point, and it's going to be the intersection of the lines. Okay. Now what you've got is you've got two individual lines that are broken there, and so you can just change the layer of the one that you want. Okay. So that's the easy part once you figure out what you want. The circles up here, we need a hidden line on the circles also. Let's say I've got this one down here done. We need a hidden line there because that part is not visible to us. And I found the easiest way to deal with that is I went ahead and just temporarily put all my circles on the construction layer or change colors of them. I put them on construction layer so I can turn them on, turn them off. Okay, then I copied one of the circles over and made a hidden line, put it on the hidden layer. Okay, so I've got one to copy and paste with. And well, let me go ahead and put another line in on, excuse me, let me go ahead and draw a couple more lines here. So I'm going to go line, tangent, and come down to here, tangent. And I'm going to repeat that. Now, you can't copy, like, I couldn't have drawn this line and then copied it to here because the tangent points are different. Okay, so don't get fooled into that. All right, so now then with this one, this line segment right here is going to be a hidden line. Okay, so I'll do my break. And move that over to the hidden layer. Okay, now the circle up here, whatever is not between the visible lines that are in the front. Okay, so these two parts right here are the visible portion of it in the front of the coil. So whatever is between those two is going to be hidden. I can do a 2-point break, but often that deletes out the part that you're trying to trim. So I could do 2 single-point breaks, or I could do a trim. There's a lot of different ways to work your way around this. So let me work with a single-point break here on this one. So I'm going to select my circle. I want to break it where this one becomes tangent, right there. Oh, single-point break don't work on circles. Sorry about that. Okay, so we'll go back to the other way I was doing it. I'll take one of these and copy it. Put it right on top of the existing one. Now let's turn off our hidden layer. You could have done this, before if you wanted to. So I want to trim out the part of the circle up to where it becomes tangent with this part of the coil is coming down. Okay, so I've got that trimmed around. Now I want to turn my hidden layer back on. And I want to trim this one in the same manner. The hidden line, I want to trim it at the top though. And so it may be easier to turn off my construction layer. Or I could freeze it. Okay, you could freeze it, that'd work too. And that gets a little bit more. So you can see it goes from that part to that part. And now I'll turn that construction layer back on. If I click on that one, you can see the 2 endpoints, and then click on this one, I see the same 2 endpoints. Okay, and then once I get it done, switch it back over to my visible layer. Okay, now once you've got the top one of these at the top done here in the middle, you could copy it to this one. Okay, same way down here. Once you get one done here, you could copy it to here and copy it to here, and you'd be good. The ends are different. It's just the way that the things work out. Okay, so that's got you through a lot of how this thing is going to look. Remember, all of these lines are tangents. They do not go to the quadrants except for that very first one right there. And this one that comes up right there. I think that one's on. So don't get tricked in thinking you just do quadrants. And you're going to do an end view that has your pitch diameter as the center line. And then, of course, the diameter of the wire for the interior and exterior. And because we're starting this coil here coming to the front on this one, that's the ending point right there of the spring. And that's how that's done. And then you'll have a note on your drawing. You'll have a general note that has the wire diameter, pitch total number of coils. Okay. And then you can dimension the overall length of your spring. And that's how you draw. Look at my notes here. That's how you would draw a 5-coil left-hand helical compression spring with ends squared and ground. I know you've always been wondering how to do that your entire life, and now you know, and you can do it. If you got questions, come see me in the lab, send us an email, okay?